Folks, it is 10:20, so we will get started. All right. So if you haven't logged in yet, please do so. All right, so as promised, we will discuss the terms and conditions of the exam that's coming up. So the exam covers chapters 2, 3, 4, 5, and 10. Exam 2 will start with today's lecture. So you'll have a full week to cover all the chapters, any points, any homeworks that we've already assigned, and get your questions in. And of course, the week of the exam, you will not have homework due, as you may already know from your syllabus. But for those that are trickling in, I am taking attendance, so please log that in. But I will move on from this screen so that I can show you where all this information is so that you don't have to write this down, nor do you have to remember off, right? So let's go to that. So where is this page? So if you go to Home, and under Exams, you see Exam 1 Guide and Resources. Okay. You also see all of the announcements that have been made in the class thus far. So this way you can Control F and find whatever it is that you need. So before the exam, this will be a digital exam. This is something new for this class. And so we are somewhere in between catching up with other departments that have already offered online type exams. But for us, this is a new teaching model as well as a new exam model. So to get us all on the same page, we will create a practice exam on Carmen itself to mimic the testing environment that you'll experience during the exam itself, which means we ask that before the exam, you take the practice exam to familiarize yourself on how to input your answers, things like that. But also, there will be questions that are similar, not identical, similar in style to the exam itself. Okay? So that's why it says before the exam, before the 21st, which is your exam date, we ask that you log in, click around, and then submit your practice exam. Obviously, if you get answers wrong on your practice exam, it's not counted against you or anything like that, but it forces you to practice so that on the day that you take the exam, you will not have any technical glitches based on being unfamiliar with the interface, okay? All right, so that's before the exam. That's before the 21st of February. Okay? Now, what else should you expect and what are the resources that are available for you? So here's the format of the exam itself. I'm going to spell it out, okay, even though it's written here. So Exam 1 materials covers chapters 2, 3, 4, 5, and 10. Yes?
So the exam time, is it like that Thursday and Friday, or is it the 20th and the 21st?
Yes, so hold that thought. So I will go into great detail and expand upon all of this. So originally on your syllabus, it says Exam 1, and it says in class, right? That's your class time is 55 minutes. So we are giving you the whole 55 minutes to take your exam, but you have the added bonus of taking it whenever you wish within the open time. So what does that mean? That means the exam will open Oh, sorry, the dates are incorrect. You're right, you caught that. So Thursday should be the 20th, so we'll fix that. Somehow that slipped through. Is that true? Yeah, no, sorry, the Friday is the 21st. So this should be, this right here, I can actually change that. Let me edit that real fast to correct the date. One moment. So this should be the 20th, and this should be the 21st. Save. Okay. So what does that mean for you? That means the exam will open Thursday at 5 p.m. So if you choose to start your exam on Thursday, February 20th at 5 p.m., you have until 5:55 p.m. to finish your exam. It's continuously timed. So if you're a night person, great, take it at 8 p.m. But there's an asterisk to that, so I'll get to that asterisk. And then the exam will close on the 21st at 5 p.m. So if you start your exam at 4:05 p.m. on Friday, you can complete it because it will end at 5 p.m. on Friday the 21st. So all it is it's the same amount of time you would have gotten in class, but now you can choose your testing environment and you can choose when you start your exam. Can you choose an arbitrary time like 12:01 a.m. on the 21st of February? Yes, you can, but nobody is going to be around to restart your exam if there's a glitch. Okay, so now I'm getting into specifics and exceptions, so hold that thought if there are questions in regards to what happens when you take your exam at 3 in the morning, if that's the time that you do well on exams. Okay, so the combination, the questions that you'll have are, it's a combination of multiple choice, free answer input, like just the way you've been doing your homework, and also open-ended questions. Okay, so that means there isn't A, B, C, D, E to choose from, but you actually have to give your answer in written form, prose like this phase is blah, this phase is X or whatever, okay? So very similar to how you've been doing your homework right now. Either you've been given some choices to choose from, so multiple choice, or you've had to input your answer, okay? So that's point 3. Point 4, it will be open book. We will provide a link right at the beginning, at the top of your Carmen exam, with a link to your e-textbook, okay? So obviously, if you have a physical textbook, you can use it as well. Now, this relies on the honor code system that you're not using anything else, okay? Now, I've also noted at the beginning that you're allowed to have one 8.5 by 11 one-sided handwritten note sheet. We're not taking that away from you. You still get to keep that. So it's open book, and you get to have your own set of notes that you prioritize whatever it is that you want to prioritize in your own handwriting. Okay, so if it's equations, what have you, if you want to prioritize that on your single note sheet, feel free to do so. So you have those two resources at your disposal during your 55 minutes, okay? We ask that you upload your note sheet, and that will be open, and you'll have up to 24 hours to upload that. And if you don't use a note sheet, there will be an option for you to just check, I didn't use a note sheet, and that's fine too, okay? So nothing is being taken away. In fact, things are being added to what was previously announced, although unofficially, okay? Point 6, if you have already communicated with the SLDS office that you need certain accommodations, whatever they may be, we have received those Dr. Brown and I have received the electronic notifications of that request. So he has already followed up with you, and if he has not, if it's just a time extension or something like that, that will already be reflected on your exam, okay? So you don't have to make additional meetings or appointments to go over what are the terms and conditions for the accommodations we've already received, things like that. Now, if it's beyond that, if you need, you know, either booking of an official location, that will be followed up by Dr. Brown, and that should be communicated to you. Whether it's going to be at SLDS office or testing services, if it's a, you know, whatever the accommodations are, that will be clearly communicated, okay? But since it's an open book and the time is open for 24 hours, it should take away a lot of the restraints in terms of having an in-class exam and making accommodations for that. But we are aware of all the requests that we've received so far. And closer to the date, we know that there's a 1 week deadline, 1 week before the exam deadline. So before that, you should get an email confirmation just saying, we received the request from SLDS. You know, if there's nothing to do other than just time extension or something like that, then there's nothing for you to do, okay? It should be streamlined. And of course, if you have any questions about that, just let us know. The last point, number 7, is that anybody who wish to take the exam on paper may do so. Just let us know by this date that you see here. You need to alert Dr. Brown by Friday the 14th at 9 in the morning so that we just make enough copies, right? We don't want to unnecessarily print out exams, but obviously we want to be prepared for the number of people that do request that. And you can take it here in class because obviously we have this room reserved for us for the 55-minute lecture that we usually have Monday, Wednesday, Friday. And of course, if you have any additional accommodations requests, if you wish to take it at those locations with the paper exam, let us know as well. Although that should already have been noted in your SLDS request, okay? But if that changes between now and the 14th, just please email Dr. Brown, CC me, and we'll get all of the administrative things taken care of. Okay, so those are the 7 major points. Clarification question. How many questions will it be? There will be enough questions that will allow you to take it within 55 minutes. It is single-sided. So that means you write on one side and the other side is blank. So we request that you upload that, and it is based on the honor code as well. Okay? Now, based on the practice exam, you may anticipate the answer to that question, how many questions will be on the exam, because it will be similar. Now, will it be plus or minus 1 question? Potentially. But it won't be like, we'll give you a practice exam for 5 questions, and then the exam will be 40 questions. It won't be so dissimilar, okay? But it won't be exact. So do not expect, if your practice exam has 15 questions, don't expect exactly 15 questions in the same order, right? We just want you to get a feel for the multiple choice style, for the input style, so that we get rid of all the things that we can avoid, such as how do I input this, or if I have a selection error, or my account gets logged out. Just things like that. We want to catch this beforehand and give you the opportunity to ask any questions about, like, you know, how do I put in a square root, or whatever it may be. You know, I think at this point you're pretty familiar with how to input mathematical expressions, but this is just added practice with questions that are similar in style to the exam itself, so that you're not surprised that you have conceptual questions and quantitative questions. Okay? That's as transparent as we can be. Correct. When you take the exam, is it continuous? Yes, it is. So if you hit start at a certain time, count 55 minutes, and then you're timed out. That's it. Like, there is no, let's start at 10 a.m., go for a coffee break at 10:30, come back at noon. No, it will not be something where you have a total of 24 hours. It's just the exam window is open for 24 hours. But once you start, the clock ticks, and you have 55 minutes or whatever time that is based on your accommodations. Okay? Yes?
So just to be crystal clear,
Yes.
you've been approved for extended time
Mhm.
for SLDS. That's going to be updated through Carmen.
Yep. Yep. Exactly. Just like with homework, if there's any extension request, it should have already been reflected on that. So, and we will be very crystal clear so that you don't have to guess, am I already in the system? You will get an email from us that says, hello, we see that you've submitted a request. It has been reflected. Now, as soon as you start your exam, if there's anything that is unexpected, let's say there's a clerical error and somebody forgot to put in the extension, or whatever it is it may be, if you notice anything, there will be a way for you to ping all of the instructional team. So that gets me to the second point, the human availability during 24-hour period for clarification questions. So we realize that technology is not perfect. I've demonstrated that technology is imperfect. So what we want to do is minimize all of those distractions for you while providing you flexible exam, a flexible exam. Okay, so what does that mean? That means your TAs will be on call and available for questions during chunks of time. Okay, so what does that mean? So from 5 to 6 Thursday, which is Felipe's usual office hours, he'll be on call. So if you ping the entire instructional team, for a clarification, right? If you were taking the exam in class, you would just probably come down and we would clarify the question for you if you had any questions about it, right? But if, since you're taking it online, that's going to be difficult, right? We're not going to be wherever you are going to be when you're taking the exam. So between 5 and 6, somebody will be, so Felipe will be on call to answer your questions. 8 to 9 will be Tony. So what happens between 6 p.m. and 8 a.m.? Yeah, exactly. Okay, so then 10:20 to 11:15 Friday, Felipe will be here in class to answer any questions, right? So if you ping him, he'll be here. If you're taking the exam in class, in person, with with the packet, with the exam packet, pen and paper, that sort of thing, you can come on down and ask him. Yes?
Do you have class that Friday?
No, because your colleagues may be taking the exam during the class, so there's no way. Okay, and then 1 to 2 is Brian's usual office hours, so you can ping him as well. So does this mean you're motivated to take your exam during these times? Maybe. Maybe not. The exam is designed so that there shouldn't be any confusing questions, right? It will be proofread, and it will be taken by your instructional team so that we make sure any confusing wording, mathematical, clerical errors, things like that will be taken care of, okay? Yes? No. The question is there only one optional time for the paper exam? No. We can make accommodations for that. So the class time was reserved for examination time. But if you need accommodations to take the exam outside of class time, please email Dr. Brown, CC me, and what will need to happen is we will need a reasonable explanation for why the accommodation is needed. If you've already registered with SLDS, they've already sent us the paperwork. If it's something else that's related to a personal reason, we need that reason. And if it's, if you're attending a family event, whatever it is, we just need some documentation and that's it, okay? And then the exam, we can make accommodations for you to take it at testing services. Okay. Is there a specific device that you recommend us taking it on? Is the question laptop or iPad? I would say you should use the device that you're most comfortable with. If you've been okay working on your iPad and doing homework that way, and you know your system, you know your device, great. Obviously, Carmen is designed for multiple platforms across, operating systems as well. So what you've been experiencing with homework and accessing Carmen should be seamless. Okay. There should be no issue with Carmen, because it's OSU approved. It's obviously an OSU infrastructure, so we're going to just tap into the infrastructure that exists that you already know, so that the learning curve for taking this exam is minimal at best. Okay, so that's what we want to aim for. We don't want you to have to relearn new skills just to take this exam. Okay, it'll be integrated into your learning system already. Now, what happens if there is a technical glitch? Your Wi-Fi cuts out, whatever the case may be, right? Your laptop battery, goes kaput all of a sudden. I mean, we can't really anticipate things that are out of our control. If that is the case, please ping. There will be a way for you to let all the TAs and your 2 instructors know, but there will be one person on call during these specific hours, so that they'll be the lead and they'll get on it and they'll reset your exam, give you the same amount of time that is remaining back, so that you can just continue. Okay. Now, it might take a little bit of time if it's like just a reloading, if whatever it may be. We'll keep you posted and such, so that there's minimal interruption. So Thursday, 5 p.m. to 8 p.m. will be Janet. She will be the lead. So if you ping the entire team, she'll be the lead on answering that and resetting. Now, between 8 p.m. and 8 a.m., you can see Friday, 8 a.m. to 9 a.m. will be Tony. So between 8 p.m. and 8 a.m., there won't be anybody available. We'll just have to deal with it when we pick up at 8 a.m. on Friday. Okay? So I would encourage you not to take your exam like at 3 in the morning is what I'm saying. Okay? And then Friday, 9 a.m. to 1 p.m. is Felipe, and then Friday, 1 p.m. to the end of the examination. Open window, 5 p.m. will be Brian. So we don't expect you during your exam to remember, who am I supposed to email? Was it this person? Am I supposed to CC somebody? No, we don't expect you to remember all that. Just you're going to ping the entire team, but these are the people. So that means there will be someone taking the lead and taking care of all the technical glitches for you. Okay? Okay, any additional questions? Yes? Mm-hmm. Dr. Brown? Yeah, just email him so that we know how many copies to make. No. So are you saying during class time with pen and paper, or you're just going to bring your laptop to the classroom and take your exam? Yeah, so the question is, if you want to take pen and paper outside of class time. Oh yeah, just email Dr. Brown. That's it. If you want pen and paper outside of class time, we need to make accommodations at testing services so that there's somebody there to administer it and proctor it. Yeah. Yeah, so given that it's an honor system, we're not going to require you to do that.
So if there was a technical glitch, like Wi-Fi goes out
Mm-hmm.
during the exam,
Yeah.
then you contact the TAs because you took it.
No. Oh, wait.
You contact.
Oh, you being the student.
Like, yeah.
Not me.
Yeah. You, us.
Yes.
You contact the TAs and they say, okay, we'll reset the exam. Does that mean we pick up where we left off?
Mm-hmm.
Or does that mean we get a new
No, if there is a glitch and you've already spent X minutes into your exam, you restart with the balance, 55 minutes minus X, so you restart with that, and Carmen preserves what you've already put in. Barring major technical glitches, which we have seen in WileyPLUS, where when we reset something, that the answers that somebody has inputted has been discarded, we're anticipating that and putting things in place so that that doesn't happen. But basically, when we restart the exam for you due to a technical glitch like Wi-Fi cutting out or whatever the case may be, you should have all your answers that you've already inputted preserved and the remaining amount of time preserved as well. So you don't have to restart. We don't have to give you an entire 55 minutes just to input the answers that you've already put in before. Yeah, we're just trying to minimize the amount of work that you have to do while giving you the flexibility to take the exam when it is best that in the environment that is most flexible for you. Okay, so this is absolutely different than how we've been doing it in the past, but we're keeping up with the digital flagship program of Ohio State. And so I realize this class is a mixture in the sense that the timeline is that some of you have come in where OSU has administered iPads to all incoming students, but of course some of you are not first-year students. Most of you are not first-year students, right? Or even second year, so you don't have that. So if there is a device concern, let us know, okay? That's why we also administer the exam. Whatever device you have, it should really be a reliable one. And if that is a concern for whatever reason, let us know. We can try to work with you. There are programs, as in like, you can check out a laptop or you can go to a physical location that has a computer. If your computer has just died and it's being sent out back to the company to be, whatever the case may be, please let us know. The sooner the better so that we can help you with it, okay?
Is there a recommended web browser? Like, would you prefer we use Chrome for this?
Ooh. No, I personally don't have a recommendation. Whatever OSU has recommended for Carmen is what we're going to go with. But it should be a cross-platform and a cross-browser. There really should be no issues. We're just using the OSU Approved Carmen infrastructure. So it's all within Carmen. So whatever has been working for you with Carmen, just continue doing that because we're working within that system so that there's no added technological layer of like another hoop that you have to jump through, okay? Do you need to send it to the gradebook? That is a WileyPLUS question. You shouldn't have to send it to the gradebook. That's WileyPLUS. This will be Carmen. So WileyPLUS is a program that's integrated into Carmen. This will just be Carmen. So we are trying to avoid that. Yes, we hear you. We understand. We're trying to, yes. You don't have to send it to gradebook. It should be logged. You should get your score immediately. The only asterisk to that is your answers may not be revealed immediately because we've already have requests for a delay in the exam time, like the person cannot just fit into the 24-hour schedule. Since that is the case, we're just putting off revealing the answers so that everybody's on the same page. We're not trying to delay you in getting feedback or anything. It's just we want to be as fair as possible so that everybody just goes in with a blank slate. That's it. How do the what?
Prose answers that you write yourself.
Yeah. Well, yeah, so the open-ended, that won't be graded immediately. Yeah, well, we have a way of, okay, your instructional team, pizza will have to be bought, I think, for that. Yeah. But what we can do, we will get back to you. But it won't be like a month delay or anything like that. If you don't see your score immediately, do not fret. It is only because of certain administrative restrictions that we're not revealing the grade, okay? Okay, yes? That will also be clarified. So just similarly with your homework, so far, right? The sig figs will be dependent on the question itself, like what values you're given. Now, if there are answers that can be ambiguous, we'll be very clear about that, so that, you know, you're not having to input like 10 digits or something like that. That's not reasonable anyway, but the question will be very clear.
Will it just, like in WileyPLUS, it says like tolerance of plus or minus a bunch of percent. Will that be the same case for
Potentially, but the question should be configured in a way that wouldn't be an issue for you. You know, we would never ask something that, if you're having to read things off of a plot, okay, maybe small disclosure here. If that's the case, if you're reading off of a plot, we understand that you have human eyeballs, and there's only a limited resolution that you can achieve. So we would not design something where we're asking you for such, you know, point something, something, something that no human could actually ever reasonably do. Okay, one last question before I move on, because we do have to move on, but I want to get all your questions out of the way.
Do you get a copy of this after it's done?
No. An electronic copy, like, can you print it out to PDF?
If you see what you answered.
Oh, yeah. Well, so yes, your answers, of course, yeah, but we're not going to just hand you. So you will go over the exams in recitation to get any questions clarified and things like that, and you will have a record of your answers. But you can't print to, like, yeah, PDF or anything like that. Okay, so that was the last question. You may have more. You can post them to the discussion forum so that we can answer them and get everybody the same answer, and that way we'll be all on the same page, okay? This won't be the last time you can ask questions. And as your practice exam rolls out, you'll see clarity in, you know, what the style is and all of that, so that we minimize any confusion. Okay. Okay. Oh, actually, before I close the conversation, well, I closed the Q&A. But resources, just a reminder, you have access to all of this already, but for your resources, right, learning objectives, that's a good way to just go down the list and check, what do I know, what don't I know yet. Lecture slides, review those. Lecture recordings, I put a link to all the lecture recordings. Obviously your textbook, which you'll have access to, all of your homework, review that. Your recitation worksheets and solutions. Top hat questions have been aggregated from the different slide decks. So this link right here was prepared by Tony, and so he's aggregated all of the questions all in one slide deck across chapters 2, 3, 4, and 10. So if you need to go back, you can see all the answers. Also, I didn't go through all of the top hat questions that were in your slide deck during lecture. So it's an added opportunity for you to have a few extra practice problems, okay? And they're set in question, answer, so that way there's a blank slate and you can practice and then check your answer if that's how you want to use the slide deck. Any tutorial videos that I've posted so far, the link is there. And so the solutions have been worked out in these videos. Your practice exam will open 1 week before the review session, right? So there will be an in-class review session by your TA. And so that's the time for you. She'll go over some selected questions, but that will also be an opportunity for you to get any questions clarified, okay? And then, of course, the in-class review itself. Okay, so. And then I've just aggregated all your learning objectives here, even though you can go through the slide deck. Okay. With that, we should actually talk about some content. Okay. So we've been building up interatomic bond energies, right? How do atoms interact with each other? What is their equilibrium states? We talked about then how do they pack in a solid. We talked about what happens when they're in a polymer. What do the structures of those polymers look like? We've also talked about imperfections when you have point defects, line defects, area defects. And then we talked about how does that all fit into something that's useful for you? You know, how does that all fit in when you have continuous solubility in isomorphous systems, or limited solubility in eutectic systems, and limited solubility in eutectoid systems, okay? So we've built that all up, and now we're going to start on more on the properties itself, and how do we manipulate these materials, and how does that all tie back to what we've already covered, which is the atomic bonding and the atomic crystal structure itself, because it all goes back to that state. Okay. So the first set of properties we'll talk about is mechanical properties. And perhaps the majority of you are quite familiar, given your educational background or choice of major. You may be familiar with some of this terminology already, and you may be even more than just familiar. You might be quite advanced with some of this terminology, which is great and fine. What we want to do is tie that knowledge back to the atomic bonding. And if your background does not qualify for, you know, the statements that I've just said, then we're going to go over it from the beginning as well. So for some of you, this could be a review, and some of you, this is quite new, okay? But I'll introduce the terminology so that we're all on the same page when we talk about stress-strain curves, or when we talk about elastic, plastic behavior, and then how does that affect the material properties like stiffness, strength, ductility, toughness, hardness, okay? And ultimately, it gears us up for the next module where we talk about strengthening mechanisms and then eventually failure. Okay, so this is a stress-strain curve. You have in your x-axis strain, or epsilon, and it is unitless. So that's your x-axis here. Your y-axis is sigma, or the stress. And so this is a typical stress-strain curve, where you could read off sigma sub y. That's the yield strength. So that's the resistance to plastic deformation. And that is this point right here. Okay. That is not a straight line whatsoever, so let's try that again. Okay. And then you can also have the modulus of elasticity, which is the slope right here. The slope in this linear regime relates the stress to the strain, okay, as a materials property. And then you can also have what's called the tensile stress, and that's the maximum load-bearing capacity. That is the maximum stress right here. So you can read it off of the y-axis, similarly to the yield strength. And then if you take the area under the curve in just the elastic region, which is U sub r, or the yellow region right there, you can get the energy of absorption. Okay, so you can convert MPa into an energy term. And then if you take the area under the curve for this entire section right here up until the point of fracture, right there, so the entire area under the curve, right, you can get the toughness. Okay. Now hardness, you can see here is a materials property, but you have to do additional experiments where you can see how resistant it is to indentation. And there are several techniques for which you can implement to measure the hardness, and there are different scalings that we'll talk about. We can also talk about flexural strength when it comes to ceramic materials, because they don't behave the same way as a metal, say. So this is a typical stress strain curve for a metal, where you have some ductility here. You'd see this region is elongated. We could also have what's called the relaxation modulus. And so basically you can apply some stress, hold it, watch it over time, and measure that property within a polymer material. So the way this chapter is outlined is we'll talk about mechanical properties amongst all three different types of materials: metal, ceramics, polymers. Okay? So some of the terminology we can apply to all three materials, some we cannot, just because when you talk about ductility in ceramics, it's not a fruitful conversation given how brittle ceramics are, right? So, but there is some overlapping in terminology, and so we'll distinguish all of those parameters in this module. Okay, so stress strain curve. This won't be the last time you see this. We'll break it down throughout the lecture. Okay, so when we talk about stress states, how do we do these experiments, right? Some of you may have taken a lab where you've already implemented this, but if you have not, the way you would do it is you can apply a load or some sort of force in tension, in compression, in an idealistic world, okay? You can measure the force, because you know that, and then you can measure the displacement as well. And both of that information will give you data on the stress strain curve of the material, and you just basically keep applying this load until your material fails, okay? There can be quite complex experiments that you could do, but in this class we're only going to focus on some of the more simple type experiments, but even those are, can be quite involved if you're really trying to tease out the atomic information. Okay, so what we're really talking about is the engineering stress and strain. What that means is, as we're deforming this material by applying a load of some sort, we're not instantaneously measuring the changes in deformation, right? Let's say you start off with something, okay. Let's say you start off with two types of materials. One that happens to be the same length as this material here, and the cross-sectional area is what's different about them. So this A is going to be different, right? But let's say you apply the same force or the same load. In this case, it's in tension. You're pulling it away, okay? Well, F is going to be the same. So your stress is going to be different between these two materials because they have different cross-sectional area. So they could be the same material, they could not, but the cross-sectional area is different here, and thus the stress, the engineering stress, is different. Okay? And then of course we can measure experimentally what this elongation is going to be when we apply this load by just measuring the delta L, right, that change, and then we take the change divided by the original length, L naught. It will give us the strain, right? It will give us our x-axis, and we can calculate what our y-axis is in our stress strain curve. Okay, so this is obviously just a schematic of these types of experiments right? What's good about this type of relationship is that it takes out your dimension, right? It takes out the cross-sectional area because it's already been normalized by that. So when you report stress and strain, right, you're talking about the property itself, and you don't have to ask somebody, was it a wire that you tested it on? Was it, you know, a big slab that you tested it on? Because that's already been normalized by dividing by the cross-sectional area. So now these numbers give us an indication of how relative they are, relative, you know, as compared to other types of materials. So then we can start tabulating these stresses and strains for, let's say, metals, ceramics, polymers, because it's now unitless. Okay. So you could see epsilon is unitless because you just have, you know, something like meters divided by meters, or millimeters divided by millimeters, which is more realistic. So it's unitless. Okay. Okay. So that's useful. We typically use the units of MPa for these types of materials. They can go up to as high as gigapascal GPa, depending on the strength of your material, but these are pretty common. And if you recall the relationship between megapascals and newtons per meter squared, it's just 1 MPa is 10 to the 6. So GPa, gigapascal, will be 10 to the 9 newtons per meter squared. Okay. And so this is useful for numbers for ceramics and metals. For polymers, this number could be quite low. It could be fractional. It could be 0.1 or 0.3 MPa, something like that. So this unit covers the range of metals, ceramics, and polymers quite well without having you write a bunch of decimals. Okay. Okay. So what's happening when we pull this in tension? We'll go into this a little bit more detail if we get to the video in time. But basically, you have this linear region. You have your sample that looks like this sort of dog bone type sample where you are inducing the breakage somewhere in that section, in the gauge length. You'll experience a linear regime, and then, you know, your stress will actually decrease because this is engineering stress, and you're normalizing by the initial cross-sectional area. So what I said before about measuring instantaneous changes in your cross-sectional area, right? This cross-sectional area, as you could see here, is changing quite a bit, and after necking, after this point right here, you could see it decreasing a little bit, and then it gets to some very small region, and then it breaks. Okay, so what's happening is this entire curve is divided by the original A naught. Even though the cross-sectional area is changing, we're not dividing by that instantaneous cross-sectional area at any given time. If we were, we'll go into true stress and strain. You would look more something like this. Okay. In the interest of time, I'll save the video for next time, but this is also through your WileyPLUS. If you go into the section on mechanical properties, tensile stretching, this is what you would see. And I should note this X right here is the point of fracture, right? And once something fractures, that's it. I mean, you really don't have any more information on it. So what you'd be interested in as an engineer is what happens right before that fracture. And that's difficult to achieve. It's not impossible, but it is difficult because if your material is about to fail, right, catching it right before it fails in terms of understanding what's happening atomically is difficult. But we can sort of tease out that information with the stress strain curve and make some extrapolations about what's happening to the material. Okay. So you'll see these equations quite a bit again and again. If you're applying a load in tension here with some starting material that has cross-sectional area A0, you can imagine that as it's elongating, that there's going to be some contraction laterally, okay, to conserve mass, right? You're elongating it, so now laterally it's contracting. And vice versa for compression, if you're squeezing something, you can imagine increase in the lateral direction as well to compensate. So we can track all of that. We can put in markers in our testing devices to measure the elongation. So that's L minus L0, so L being the final length. Sometimes you'll see it as LF. That gives us the delta L divided by L0. And then the lateral strain will just be the final width minus the initial width. Now, if it's contracting, you could also think of it as, just the change, the delta W. Okay. So that could affect your signs a little bit, but it should not affect your magnitude. What kind of stresses can we apply? We can apply stress in tension. So here you see the arrow pointing this way. So we're pulling. Okay. So you could see here before you have cross-sectional area A0. That changes a little bit. It gets a little bit smaller because of contraction in the lateral direction. You can also have compression, as seen here, where you're applying the load this way. You can have shear. Okay, so you can see here the force is being experienced this way on the top, this way on the bottom, and this way on the side. So you can have a combination. So that's shear. And then, of course, you could also have some combination where there's an angle dependence. So you can rotate it in some angle, and it's sort of like this. Okay. And honestly, in the real world, you're going to have something that is shear and torsion realistically, even though we try to make it as normal to the cross-sectional area as possible in tension or compression. Okay. Okay. We'll start on tension, and I believe that's where we're going to be. But a good example of things being in tension is this cable here. Right? This was from Pete Anderson back in the day. And you can see this cable as it's pulling these, the chairs in the ski lift, right? That's, the cable itself is in tension. So you can measure the stress on it over time. Well, this is static, but you can do it over time. But if it were static, you can just, once again, calculate the stress based on the load that you apply in tension divided by the cross-sectional area of this material. So it's a cable, so it's cylindrical, right, a circle. You can measure the elongation, so that's just delta L divided by L0. So pretty straightforward. Okay. Compression is the same, but in the opposite direction. So it's the negative of tension. Okay. So you could see, where would the cross-sectional area be in this image? It would be right here. Your A0 would be right here, where it's experiencing the load of the rock that's on top of it. And you can measure the stress and the strain in this particular example as well. Okay, we'll pick up here next time. Have a good weekend. Yeah.
Do we need it to install some kind of extension or something on our browser?
I don't think so.
Okay.
Yeah.
Because when you put this, it talks about
Proctorio. Yeah. That could be. So you would go, if you didn't already have this. Hold on.